Hello and welcome once again to the Akash Byju's JEE channel. My name is Atiullah and we are live once again with the AIM JEE 2025 series. Alright everyone who is here, quickly give me a thumbs up, quickly give me a yes. Jaldi jaldi apni attendance laga do and then very quickly we are going to start the session. Alright, कौन आ चुका है? Raj Nandini is here, Aditya is here, Gaurav is here, Parvati is here. Alright, Nagaraj is here. Good evening everyone. Good evening, very warm welcome to this session. So what are we going to do today? We are going to take up vector addition and we are going to go a step further in that. So in the last session we had talked about the triangular law of addition. We had talked about the parallelogram law of addition. So we are going to continue our discussion of vector addition and we are going to learn the analytical method of vector addition, which is very important. Okay, that is the main formula or that is the main concept that you need to know when we talk about vector addition. All right, a lot of people have joined. Chalo, everyone, quickly give me a thumbs up, quickly give me a yes if you are ready, and then we are going to get started with this session. Aditya is saying, can I ask a question? Of course, you can ask a question. Polygon law of addition is pending. Yes, you are absolutely right. Polygon law of addition is pending and that is what we are going to start with. चलो, तो सबसे पहले अपन start करेंगे polygon law of addition से. But उससे पहले there are a few things that I want to convey to you. First of all, JEE Main 2023 का result आ गया and Akash Byju's students have done exceptionally well in this, and you can see that in the Akash Byju's classroom program results. We have Dhruv Sanjay Jain who have secured an All India rank of 8 and he has got a perfect 100 percentile. Also we have Kamyak Channa who has got All India rank of 21, 100 percentiler again. Then Anup Singh, All India rank 46, and there are many people. Okay, these are just a few names of the toppers, but there are many people who have done exceptionally well in Akash Byju's in JEE Main 2023. So we have Akarsh, we have Nikhilesh, we have Tanishq. These guys have secured a very good rank. Not just this, Akash Byju's live program where students were enrolled in the online classes. ये लोगों ने सिर्फ online पढ़ाई की है. Okay, they have not gone to any physical classroom. They have studied completely online and then also they have performed very well. We have Mayank who has got 100 percentile and All India rank of 34, and then we have Arnav, Anurag, Ayana, Mahir, Satyaki. They've got very good percentiles in the range of 99.94, 99.93, and there are more than 120 students who have secured more than 99 percentile in JEE Main 2023. Okay, so phenomenal result. So whether you want to study offline, whether you want to study online, whether you want to study on the app or you want to study on the YouTube channel, we are present everywhere. So there's just one place you need to go, and that is Akash Byju's JEE. Alright, chalo, with that said, let's get started with this session. And the first thing we want to discuss is the polygon law of addition. Okay. About the books, about everything else, हम लोग बात करेंगे, ठीक है आदित्य? About what books you should follow, what are the things you should do regarding books, that we are going to talk at the end of the session. पहले थोड़ी पढ़ाई करते हैं. Let's start with the concepts. Alright, चलो. So let's get started. Alright, तो polygon law of addition is a extension of the triangular law of addition. Okay, so what does polygon law of addition say? Polygon law of addition says a very complicated statement. Okay, if you look at it, what is the statement? The polygon law of vector addition states that if a number of vectors can be represented in magnitude and direction by the sides of a polygon taken in same order, then the resultant is represented in magnitude and direction by closing the side of the polygon taken in the opposite order. How many of you understood this statement? This long tedious statement. How many of you guys understood this statement? Can you explain? Can someone explain? अनुराग बोल रहा है सर वेक्टर एडिशन का क्या नाम है एनसीईआरटी में? वेक्टर्स चैप्टर में ही होगा अनुराग. इट वुड बी इन द चैप्टर वेक्टर्स. सर 11th में मेरा ये चैप्टर नहीं हो पाया था, मैं भी पढ़ लूँ ना सर? ऑफ कोर्स शिवम, इफ अगर नहीं हो पाया था देन ऑब्वियसली यू कैन स्टडी हियर. Sir, you are the master tutor in my online classes for units and dimensions. All right. Study Sparkle. Sir, advanced के लिए easy chapter बता दीजिए. Advanced का discussion, advanced के batch में हिमांशु. Here we are talking about class 11th. Okay. So what do we have? So what I want to do is I want to show you a simulation. ठीक है. Last class also we had shown you this simulation. So simulation के साथ क्या होता है? चीजें ज़्यादा अच्छे से दिखती हैं, ज़्यादा अच्छे से समझ में आती हैं. Okay. So simulation में दिखाता हूँ vector addition का, and what we want to do is we want to have more than two vectors. Okay, so I have this one vector, इसको यहाँ निकाल लेते हैं. Then I have another vector, इसको भी निकाल लेते हैं, and then I have a third vector also. So now what I have three vectors. So let's say vector 1 is this vector, vector A. Now in polygon law of addition, what do I need to do is I need to arrange all the vectors head to tail. Is that correct? So this is just an extension of triangular law of addition. So all we have to do is add all these vectors. Let's say this is the vector. I'm going to join it. How? I'm going to join it head to tail. And then I have another vector. I'm going to join it. How? I'm going to join it head to tail. Now what does the polygon law of addition say? It says that the final vector, the resultant of these vectors, would be a vector which goes from the tail of the first vector to the head of the last vector. That is it. Plain and simple. So are you ready to see the result? So if I do the sum, you can see that this is the sum. Okay, so this is a vector, the resultant is a vector which is going from the tail of the first vector to the head of or the tip of the last vector. So this is known as polygon law of addition. Now if you have 3 vectors, if you have 4 vectors, if you have 10 vectors, it does not matter. All you have to do is you have to keep arranging the vectors head to tail. Doesn't matter what is the orientation, doesn't matter how many vectors are there. Just arrange all the vectors head to tail, and the resultant is going to be from the tail of the first to the tip of the last. This is going to be the resultant. Is this clear, everyone? So if polygon law of addition is clear, quickly give me a thumbs up, quickly give me a yes. Alright? Okay. Now what I'm going to do is I'm going to do something very interesting over here. Okay, wait for it. I'm going to do something very interesting. So what I want to do is I want to first arrange these vectors like this. So wait for it. Let me arrange 3 vectors like this. Okay, and what I want to do is I want to do a vector summation of these 3 vectors. Chalo. These are the 3 vectors. Now what I'm going to do is I'm going to rotate this vector. Look at vector B. I'm only going to rotate this vector, meaning I don't want to change its magnitude. I just want to change its direction. So I've rotated this vector something like this. Okay? And I've also rotated this vector something like this. I'm not changing the magnitude. I'm only rotating. Okay? Notice that I'm not changing the magnitude. I'm only rotating. So I have arranged the 3 vectors something like this. Okay. Now what I want to do is I want to find the sum. Okay. What do I want to do? I want to find the sum. Let's try to find out the sum. Okay. When I click on the sum vector, you see that what is the sum? Can you see what is the sum? Okay. This is the sum vector. Do you see any arrow? Do you see anything associated with this S? What has happened here? The sum has become 0. Is that right? Did you observe that? So there are 3 vectors. I have arranged them like this, and it is showing me that the vector summation is 0. Now how has that happened? That has happened, and we can observe that by using the polygon law of addition. So what I'm going to do is, if I have to add these 3 vectors, I'm going to join them head to tail. Do you agree? So I'm going to move this vector, and I'm going to join it head to tail. Then I'm going to use this, move this vector, and I'm going to join it head to tail. So what you see is that they have completed a polygon. Okay, what they have done is they have completed a polygon or completed a triangle. They have completed a closed figure. Can you see that? Now in this case, what is the tail of the first vector? This point is the tail of the first vector. And which point is the tip of the last vector? This point itself is the tip of the last vector. What does it mean? That the tip of the last vector and the tail of the first vector are coinciding. They're at the same place. Now, if there are two dots over here which are coinciding, can I draw any line between them? Can I draw any arrow between them? Which means that the summation has become what? The summation has become 0. The resultant has become 0. Now, we can extend this to polygons of any number of sides. Okay. For example, let's say I have these 5 vectors and I want to add these vectors. So what I can do is I can arrange all of these head to tail, head to tail, head to tail, and if they make a closed figure, if they make a closed polygon, what does it mean? It means that the vector summation is going to be what? It is going to be 0. Is this clear to everyone? Wasn't this interesting? Chalo fatafat mere ko batao. Is this clear to everyone? Then quickly give me a thumbs up, quickly give me a yes. Very, very important result. Okay, you can see that vector AB, I have just moved it parallelly and brought it here. Vector BC, I have just moved it parallelly and brought it here. Vector CD, I have moved it parallelly, and so on. I've just moved all the vectors parallelly, and what they have done is they have neatly made a closed polygon, which means that if any number of vectors which are joined head to tail and they are completing a polygon, in that case the vector summation is going to be 0. Is this clear? Alright, perfect. So now let's move on. Okay, so here is a question for you. Quickly read this question and try to solve it. Okay, I know you are new to vectors, but try to solve this question. Two vectors P and Q makes an angle 60 degree and 90 degree with R, and the magnitude of R is 10 Newton. Find the magnitude of P and Q, given that P plus Q is equal to R. Is the question clear? Alright, so take some time to absorb this question, attempt this question, and then I'm going to discuss it. Take your time, no rush, but give it your complete attention, attempt it properly. Chirag is saying, sir, I don't know what is the magnitude. Magnitude of a vector. Okay, how do we represent a vector? Vector has some number associated with it. Okay, let's say we are talking about velocity. So velocity can be 10 meter per second, 20 meter per second, 100 meter per second. So that quantity which is associated with that vector is called its magnitude. How large is it? Clear, Chirag? And how do we represent it? We represent a vector with an arrow. So the length of the arrow symbolizes, or the length of the vector represents the magnitude of that vector. Clear? Alright, anyone who was able to solve this question, फटाफट बताओ मुझे, निकला आंसर कि नहीं निकला? चलो, let's think about this. We have vector R like this. Let's say vector R is like this. Yes, Chirag, numerical value. You're absolutely right. Now vector P is making an angle of 60 degree and vector Q is making an angle of 90 degree. And what we know is that P plus Q is equal to R. Okay. So if we draw vector P, how should we draw vector P? Can you show me that how we have drawn vector P, Q and R? So if this is vector R, vector P is making 60 degree. So what I'm going to do is I'm going to draw vector P like this. How much is this angle? This angle is 60 degree. But what I know is that P plus Q should be equal to R. Okay, and what is Q? Q is making an angle 90 degree with vector R. So how should I draw this vector? Obviously, if I draw P and Q head to tail, then the tail of the first vector and the tip of the last vector, they should give me the resultant. So this tells me that this is the position in which the head of Q should be there, and this is the position where the tail of Q should be there, and this vector Q is making 90 degree with the resultant, which means the vector Q has to be something like this. This is vector q. Now you can see that p plus q, we have joined them head to tail. So from the tail of p to the head of q is the resultant. Is that right? Now if I know this, I know that r vector has a magnitude of 10 Newton, then obviously I can find out what is pq. All of this is simple trigonometry. So what I can say is that cos 60 degree is equal to how much? Cos 60 degree is equal to base upon hypotenuse. So the base is 10, and what is the hypotenuse? The hypotenuse is the magnitude of p. So magnitude of p is going to become how much? Cos 60 degree is 1 by 2. So this is going to become 20 Newton. Is that correct? Similarly, we can find out for vector q also. How are we going to find out? We can say that tan 60 degree is equal to vector q magnitude divided by, what is the base? The base is 10. So this becomes, this is root 3. So the magnitude of q is going to become 10 root 3 Newton. Is this clear, everyone? Alright, so the magnitude of p is going to be 20 Newton and the magnitude of q is going to be 10 root 3 Newton. I hope this is clear to everyone. And then if this is clear, quickly give me a thumbs up, quickly give me a yes. तुषार एडवांस की क्लास कल 11 AM होगी. Okay, we are going to discuss Doppler effect in detail. So tomorrow 11 AM, I'm going to see you guys in the advanced class. Alright, done? Chaliye, perfect. Okay, so we have understood what is the triangular law of addition, we have understood what is the parallelogram law of addition, we have understood what is the polygon law of addition. But all these methods are graphical methods. So graphical method mein you need a lot of geometry, you need a lot of trigonometry. And if I have something which is not very trigonometry or geometrically friendly, in that case I'm going to have a lot of trouble. For example, let's say this vector is 4 units and this vector is 6 units and the angle between them is 60 degree. Now if I want you to find out the resultant of these two vectors, it is going to be geometrically very challenging. Do you agree or not? Think about it. So what I'm going to do is I'm going to complete the parallelogram. So this is going to be the resultant. Now the challenge is that you have to find out the length of this resultant and then you have to find out this angle. If you try to do it geometrically, it is going to be quite challenging. That is why what we have is, we have something called the analytical method of vector addition. That is very, very important. And that's what I want to derive for you. Okay. Now there are two vectors, vector p and vector q. And the angle between the vectors is theta. So what I want to do is, I want to find out what is the magnitude of the resultant, and I also want to find out what is the angle the resultant is making with the vector p. So for that, what I'm going to do is, I'm going to do something like this. So first of all, what I need to do is, I need to complete this parallelogram. The first step is to complete this parallelogram. Do you agree? So what will be the length of this side? The length of this side is going to be p. And what is the length of this side going to be? The length of this side is still going to be q. So what is the resultant? This vector is going to be the resultant. Let's call it r. I want to find out what is the magnitude of r, or what is the length of this diagonal. Okay. So how do we do that? So what I'm going to do is, I'm going to extend this line over here, and I'm going to extend this line over here, and I'm going to drop a perpendicular. I'm going to call this, let's say, x, and I'm going to call it y. Now think about this. Look at triangle AXY. Okay, just look at triangle AXY. So if I'm able to find out xy, and if I'm able to find out ay, then the resultant is simply going to be the hypotenuse of this right angle triangle. Can you see that? So my objective is to find out what is xy, and my objective is to find out what is ay. So let's try to do this. Now what I know is that this triangle, in triangle XBY, can you see this triangle? Triangle XBY. Okay. Now this AC and BX are parallel to each other. AC and bx are parallel to each other. So by the property of corresponding angles, this angle is also going to be theta. Okay. What is the length of bx? The length of bx is q. So using that, can I find what is xy? Okay, what I'm going to do is, I'm going to say that sine theta is equal to xy divided by what? Divided by px. And what is the length of bx? The length of bx is q. So xy is going to be q sine theta. Do you agree? And what I also want to find out is, I want to find out what is by. How do I find out by? I'm going to say that cos theta in the triangle bxy, cos theta will be equal to by divided by how much? Divided by bx again, the hypotenuse. And what is the length of the hypotenuse? That is q. So from here we can say that by is equal to q cos theta. Now this length, AB length is how much? It is P. And BY length is how much? This is Q cos theta. So this entire length is going to become P plus Q cos theta. Do you agree? And what is this length XY? This length XY is Q sin theta. So what I have done is, I have found out what is the length of side XY and what is the length of side AY. Now the resultant, the length of the resultant or the magnitude of the resultant is simply going to be what? It is, we can use the Pythagoras theorem to do that. So the magnitude of R square, or we can simply write it as R square, right? So R square will be equal to Q sin theta square plus P plus Q cos theta square. Is this clear or not? Okay, everyone, if this is clear, quickly give me a thumbs up, quickly give me a yes. Then we are going to solve it and we are going to find out the final result. But abhi tak, whatever we have done, is this clear? Quickly give me a thumbs up, quickly give me a yes. Okay, very nice. So now let's take this a step further. So this is going to become R square is equal to Q square sin square theta, and when we open the bracket for P plus Q cos theta, let's square it. So this is going to become R square is equal to Q square sin square theta plus this is going to become P square plus Q square cos square theta plus 2PQ cos theta. Simply I have opened the bracket, A plus B whole square. Okay. Now Q square sin square theta and Q square sin square cos square theta, we can join these terms. So this is going to become R square is equal to, if we take Q square common, we'll have sin square theta plus cos square theta. And what is sin square theta plus cos square theta? It is simply 1. So this is going to become Q square plus P square plus 2PQ cos theta, which means finally the value of the resultant is going to be the under root of P square plus Q square plus 2PQ cos theta. Is this clear? So if I know what is the magnitude of P, if I know what is the magnitude of Q, and if we know what is the angle between the vectors, I can find out what will be the magnitude of the resultant. If this is clear, quickly give me a thumbs up. Clear? Okay. Now in case of a vector, when we are finding the resultant, the magnitude is not enough. The magnitude is not enough. What we also need to find out that what is the direction. And how can we tell that the direction? So we can say that the vector R is making an angle alpha with vector P. Okay, vector R, what angle it is making? It is making an angle alpha with vector P. Can I find this vector alpha? Sorry, can I find this angle alpha? Okay, so we'll have to go back to our triangle over here. Now look at the triangle AXY. Look at the triangle AXY. What is this? This angle is alpha. The angle the resultant is making with the P vector. What angle is that? That angle is alpha. Now if you look at triangle AXY, can you find out what is alpha? Tell me, suggest, how do we find alpha in the triangle AXY? The hint is right there. AXY is a right angle triangle. You know the sides of this right angle triangle? Yes, very good, Soham. So what we're going to do is we can use tan alpha. In triangle AXY, use tan alpha. So tan alpha will be equal to what? Perpendicular. What is the perpendicular? Q sine theta is the perpendicular. Divided by, what is the base? The base is P plus Q cos theta. So if you know the magnitude of P, you know the magnitude of Q, and you know the angle between the vectors, then you can find alpha as well. Tan alpha will be equal to Q sine theta divided by P plus Q cos theta. Is this clear, everyone? Now this is known as the analytical method of vector addition, and let me summarize it like this. It is going to be used again and again and again. So make sure that you understand this very well. Take some time to absorb this. If you have any confusion, you can ask me right away. Don't hesitate to ask me. You can ask me right away if there is any confusion. Otherwise, if this is clear, we are going to move forward. This is useful in class 12 also. Soham, this is going to be used till the day you are studying physics. This is going to be very useful. Alright, done? Chaliye. So let's move to the next part. Now what we want to do is we want to think of some special cases. Okay. Resultant is under root of P square plus Q square plus 2 PQ cos theta. Now what we want to do is we want to look at some special cases. What are the special cases? When P and Q are parallel. If P and Q are parallel, what does it mean? It means that the angle between them is 0 degree. And if the angle between them is 0 degree, then cos 0 is going to be how much? Cos 0 is going to be 1. So what are we going to get? We are going to get the resultant as the under root of P square plus Q square plus 2PQ. Does this ring a bell? P square plus Q square plus 2PQ. Can I say it is P plus Q whole square? And if I do an under root, what do I get? I get P plus Q. Which means that the magnitude of the resultant simply becomes the magnitude of P plus the magnitude of Q. Do you get this? Okay. So let me show you in a simulation. So what I can do is I can make you visualize this. How do I visualize this? Very simple. Chalo. So what do I have? Let's say I have vector A. Like this. What is the length of vector A? The length of vector A is 10 units. And let's say I have vector B. The length of vector B is how much? It is 5 units. I want to add these two vectors. Okay. So what we have just understood is that if the angle between them is 0 degree, join them tail to tail. What is the angle between them? The angle between them is 0 degree. So in that case, the resultant has a magnitude of the magnitude of A plus the magnitude of B. Can we see that? Of course. In triangular law of addition, what do? We join the vectors head to tail. And when we look at the sum, what is the sum going to be? The sum is going to be something like this. Now you can see very well that what is the magnitude of this sum? The magnitude of this sum is simply equal to the magnitude of A plus the magnitude of B. What is that? That is 15 units. Do you agree? So if they are parallel to each other, simply the magnitude is going to be the sum of the magnitudes of the vectors. Correct? Okay. What is the special case number 2? The special case number 2 is when the angle between them is 180 degree. This is called anti-parallel. Vectors can be anti-parallel. So anti-parallel meaning they are pointing in opposite directions. So when theta is 180 degree, Cos theta would be how much? Cos theta is going to be -1. How many of you know that cos 180 degree is equal to -1? People who have just moved from class 10 to 11th, maybe you know, maybe you don't know, I'm not sure, but you will study it, okay? So cos 180 degree is how much? Cos 180 degree is -1. Do you know this? Now if I substitute cos 180 degree over here, I get the resultant, or the magnitude of resultant, as p square plus q square minus 2pq. Okay? Okay, so this you are going to study in mathematics when Bhumika ma'am teaches you basic trigonometry. You're going to study there. For now, just take this as a result, that cos 180 degree is equal to -1. Just take this as a result. Okay, how does it come? How do you play around with it? That you'll study in mathematics. Abhi ke liye just understand that cos 180 degree is equal to -1. Okay, so the resultant is going to be p square plus q square minus 2pq under root. Can I say this is p minus q ka square and then under root, which means it is going to become magnitude of p minus magnitude of q. I will have to put it in mod. Everyone knows what is a mod. A mod just makes things positive. Okay? Because I don't know if p is greater or q is greater. I don't know. So p minus q, the result, it can be positive, it can be negative. But the magnitude of any vector is always positive. So I'll have to put it in a mod. So what I see here is that if they are anti-parallel, then the sum is simply the difference of the magnitudes of the two vectors. Can we see it here? Let's try to see it here. Now vector A has a magnitude of 10 units, vector B has a magnitude of 5 units, but now vector B is anti-parallel, which means the angle between them is how much? The angle between them is this, 180 degree. Now if we want to add these two, how do we add these two? Simply I have to join them head to tail. So you can see that vector A was here. What I have done is I have joined vector B head to tail. Now let's look at the summation. What is the summation? The summation is right in front of you. Look at the summation. This is the summation. So the summation has become 10 minus 5 is equal to 5. Is this clear? So the second special case, I hope, is also clear. And then there is a third special case. We're going to talk about the third special case, but before that, we understand that the range of the resultant, okay, the range of the resultant is going to lie between these two things. What is the maximum value of resultant? The maximum value of resultant is going to be magnitude of p plus magnitude of q, in case the angle between them is 0 degree. And what will be the minimum magnitude of the resultant? The minimum magnitude would be magnitude of p minus q. I have to put that in mod. And that is going to be the minimum magnitude of the resultant. So the summation of two vectors can have a maximum value of p plus q and can have a minimum value of p minus q. So Soham is saying, sir, so the range of resultant of two vectors lies between the magnitudes when angle is 0 and 180 degree. You are absolutely right. Absolutely right. So dekh lo. You can see this. Okay, let me show it to you. Just concentrate on the resultant. Just concentrate on vector S. Okay, just concentrate on vector S. So what I'm going to do is I'm going to keep the magnitude of A and I'm going to keep the magnitude of B constant. I'm not going to change the magnitude. I'm simply going to change the angle between the vectors. So I'm going to rotate vector B. Okay, I need to rotate vector B. So now what you see is what is happening to the resultant. You just observe what is happening to the resultant. I'm not changing the magnitude and I'm only rotating the vector. Are you able to understand this? Should I show you again? ठीक है, चलो let me show this to you again. Abhi, what is the angle between the vectors? The angle between the vectors is 0 degree. Now what I'm going to do is I'm going to rotate vector B. I'm not changing the magnitude, I'm just rotating it. So what do you see? What do you observe? That the magnitude of the resultant has reduced. The magnitude of vector S has reduced. Now rotate it further, rotate it further, rotate it further. So you see that the magnitude is decreasing, 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 and here the magnitude is going to be minimum. Is this clear everyone? चलो ये visualization देख के मजा आया या नहीं? अगर आया then quickly give me a thumbs up, quickly give me a yes. Very nice. चलिए. Now there is one more special case. Acha, that special case is not given, but we should discuss that special case. Okay. One more special case is there, wherein cos theta is equal, theta is equal to 90 degree. Alright. A special case is there when theta is equal to 90 degree. This is also something that is going to be used very frequently. Okay. Now if theta is equal to 90 degree, then what is cos theta? Cos theta will be equal to what? It is going to be equal to 0. Then the resultant is going to be equal to under root of p square plus q square. Simple. Plain and simple. I hope you understand this. So if we have two vectors which are at 90 degree, then the resultant is simply going to be equal to the under root of p square plus q square. And we can see that here as well. Okay, that's very simple to see. Dekh lo. Vector A and vector B are perpendicular to each other. So vector S, this is the summation. And what will be the length of this summation? The length of this summation is simply going to be what? This is a right angle triangle. So the length of the resultant vector is simply going to be the hypotenuse of this triangle. So it is going to be a square plus b square under root. So these three special cases are very important so that we can calculate the vector summation very quickly. Clear everyone? Okay, so I hope you are clear with the analytical method of using vector addition. Alright. Now I want to talk about two more special cases. These two special cases are very, very important. So whatever I'm going to use here, it might happen that the trigonometry associated with that, you don't know it very well. That's fine. You can always learn that later, but these two special cases are extremely important. What is the special case? That the addition of vectors which are equal in magnitude. Let's say this is vector P. It has a magnitude P. And then let's say this is vector Q. But the magnitude of vector P is equal to the magnitude of vector Q. And the angle between them is theta. So let's try to find out what will be the resultant. Okay, so the resultant in this case, the magnitude of the resultant is going to be how much? It is going to be p square plus q square plus 2pq cos theta. Yes or no? Okay. So this is going to be, I can substitute q for p. So this becomes p square plus p square 2p square cos theta. So I get something like this. So this becomes the under root of how much? 2p square plus 2p square cos theta. Simple calculation. Now I am going to take 2p square common. So this becomes 1 plus cos theta. Now this trigonometric result I am using, you might not know it. Okay, it may happen that you might not know it, but just use it as a result. Later in trigonometry class, you'll understand how does it come. Okay. So cos theta can be written as cos square, 2 cos square theta by 2 minus 1. I know this is new for you. I know you would not know it. It's alright. Just take it as a result. Cos theta can be written as 2 cos square theta by 2 minus 1. So this cos theta here, I'm going to substitute it. So this becomes under root of 2p square 1 plus the value of cos theta is 2 cos square theta by 2 minus 1. So this 1 and this 1 is gone. So we have 4p square cos square theta by 2. So if we take an under root of all of this, we are going to get 2p cos theta by 2. Is this clear? I know that this result is very alien to you, I understand that. But if we know that there is some result like this, and if we can use it, then the resultant will have a magnitude of this 2p cos theta by 2. Okay? So if I have to give you an example, let's say this vector has magnitude 10, this vector also has a magnitude 10, and the angle between them is 60 degree. So these are two vectors which have equal magnitude and the angle between them is 60 degree. So the value magnitude of the resultant, we don't have to use the entire thing. We can simply say that it will be equal to 2 into p, and this will become cos theta by 2. The angle here is 60 degree. So half of that angle is going to be 30 degree. So this is going to become 10 root 3. Is this clear? So this is how we can use and directly find the resultant if we have two vectors which are equal in magnitude. Is this clear? Quickly give me a thumbs up if this is clear. Okay. Now what about the resultant? What about the angle of the resultant? Think about it. Now what I have to do is I have to complete this parallelogram. And if I have complete this parallelogram, then the resultant is going to be something like this. Now if both the sides are equal, then what is this? This has become a rhombus. Do you agree? If the adjacent sides are equal, then what has this become? This has become a rhombus. Do you agree? Let's say this is vector P. Let's say this is vector Q. The angle between them is theta, but the magnitude of vector P is equal to the magnitude of vector Q. Now when I complete this parallelogram, it simply becomes a rhombus. And this is going to be the resultant. So do we know that in a rhombus, this diagonal is going to bisect this angle? Do you know this property or not? In a rhombus, the diagonal is going to bisect the angle. Do you know this property? Mohammed is saying, sir, what can I do? I didn't watch earlier classes. Koi baat nahi, Mohammed. You concentrate on this class. After this session, you go back and watch that first class. Okay? Chaliye. So what it tells me is that this is a very interesting situation where if there are two vectors which are equal in magnitude, one, the resultant will be 2p cos theta by 2, number one, and the other very important result is that the vector, the resultant is going to be along the angle bisector of the vectors. For example, if I have, let's say, a vector of magnitude 10 and I have a vector of magnitude 10, the angle between them is 90 degree. So I know that the resultant is going to go right through the middle. The resultant is going to be an angle bisector of this angle. So this angle is going to be 45 degree, this angle is going to be 45 degree. Let's say if this is 10 and this is 10 and this angle is 120 degree. The angle between them is 120 degree. So if we complete this parallelogram, the resultant is going to go through the angle bisector. So this angle is going to become 60 degree and this angle is also going to become 60 degree. Are these two results absolutely clear? If they are clear, quickly give me a thumbs up. Alright, so I'm saying this again. When we are adding two vectors which have the same magnitude, the first thing is that the resultant is going to become 2p cos theta by 2. First thing. The second thing is that the resultant is going to pass through the angle bisector. It is going to pass through the middle, smack in the middle. It is going to pass through the angle bisector. Is this clear? Okay? Chaliye, very nice. So now I'm going to move forward and let's look at some properties of vector addition. Okay. First property of vector addition is that only vectors of same nature can be added. Do you get this? If we are adding velocities, we can only add velocities. Can I add velocity and displacement? Can I add two different physical quantities? I cannot do that. Like it said, we cannot add apples and oranges. So if I am adding velocity with displacement, that does not make sense. I can add displacement to displacement. I can add force to force. I can add velocity to velocity. Okay, so of the same nature, quantities of the same nature or vectors of the same nature can be added. Otherwise, obviously they cannot be added. The second thing is the vector addition is commutative. What does commutative mean? That a plus b will be equal to b plus a. Okay, a plus b will be equal to b plus a. Let's check this property. Let's try to check this property. So suppose I have two vectors a and b like this. So when I am doing a plus b, the summation is going to go from the tail of a to the head of b. But when I want to do vector b plus a, then I will join a head to tail with vector b. Now look at the resultant. Has the resultant changed? The resultant has not changed. So if you do a plus b or you do b plus a, it is still going to give you the same result. Alright. Next property is that the vector addition is associative. Associative matlab, first you find out a plus b, the resultant you add to c. That is one operation. A plus b first you find out, then the resultant you add it with c. This is going to be equal to if you first add b plus c and then add it to a. Do you want to check this? Okay, let's check if this holds true or not. So first let's take a and b and that's it. First let's take a and b. Okay, these are the two vectors a and b. So what will be the resultant of a and b? The resultant of a and b is going to be this. Now in the resultant of a and b, I'm going to add c. Okay, so let's bring in c. Let's say c is something like this. Okay, so what is the resultant of a and b? The resultant of a and b was this. The resultant of a and b, let me use this properly. So let's talk about the resultant of a and b. The resultant of a and b is going to be like this. And in the resultant of a and b, I am adding c. So the resultant of a plus b plus c is going to look something like this. So what I've done is, first I've added a and b. Then the resultant of a and b I've added with c. And this s is the final vector addition. Okay. Now can I do the reverse operation? So what I've done is, I have done a plus b plus c. Now I can do is, I can do first b plus c. And then I add it to a. Okay, let's try to do that. So vector b and vector c. So if I want to do vector b plus c first, so this is going to be the resultant of vector b plus c, right? This vector that you see here that I have drawn, this is going to be the vector b plus c. Now in b plus c, what I'm doing is I'm adding a. This is vector a. So in vector b plus c, now I'm adding vector a. So this becomes a plus b plus c. And you can see that the resultant is exactly the same. So we have verified that a plus b plus c is the same as a plus b plus c. Okay, so you see that these properties hold in addition. It seems obvious, but it's not so obvious, because in certain operations this property is not going to hold. For example, when we talk about vector subtraction, in that case this is not going to hold. Alright, so I hope this is clear. So if this is clear, let's move to the next part. Can you solve this? If the angle between the unit vectors a and b is 60 degree, then find the magnitude of a plus b. Now, do you know what is unit vectors? Unit vectors are vectors which have a magnitude of 1. So if I'm writing unit vector, its magnitude is going to be 1. Unit means 1. So unit vector means a vector which has a magnitude of 1. So a and b are two unit vectors. The angle between them is 60 degree. We have to find out the magnitude of a cap plus b cap. For unit vectors, we represent them by a cap. So this cap that you see on top of a, it represents that it is a unit vector. Chirag, are you sure? The angle between them is 60 degree. ये देखा कि नहीं देखा? Hi Harika, welcome to the session. Hello Vikas. हाँ, तो now check that उनके बीच का एंगल जो है 60 डिग्री. अब स्केलर एडिशन नहीं चल रहा है बॉस, अब वेक्टर एडिशन चल रहा है. तो दो वेक्टर्स के बीच का एंगल देखना बहुत जरूरी है. कैन यू फाइंड द आंसर? फटाफट आंसर बताओ. Hello Vikas, welcome to the session. So we are doing vectors. So there is one session that happened before last week. So you can watch that session and then you can watch this session. चलो क्या हो जाएगा? We can use the analytical method. Analytical method में क्या करना पड़ेगा? First vector का square, मतलब magnitude का square, प्लस दूसरे वेक्टर का मैग्नीट्यूड का स्क्वायर प्लस 2 इंटू द प्रोडक्ट ऑफ मैग्नीट्यूड्स ऑफ द टू वेक्टर्स. या पूरा लिखूं इसको? चलो पूरा लिख देता हूं. रिजल्टेंट का मैग्नीट्यूड क्या होता है? इट इज अंडर रूट ऑफ पी स्क्वायर प्लस क्यू स्क्वायर प्लस 2pq cos थीटा. पहले वेक्टर का मैग्नीट्यूड कितना? 1, सो दिस बिकम्स 1 स्क्वायर. दूसरे वेक्टर का मैग्नीट्यूड कितना? 1, सो दिस बिकम्स 1 स्क्वायर प्लस 2 इंटू मैग्नीट्यूड ऑफ p इंटू मैग्नीट्यूड ऑफ q इंटू cos थीटा. व्हाट इज द एंगल बिटवीन देम? 60 डिग्री. सो दिस बिकम्स cos 60 डिग्री. सो दिस इज गोइंग टू बी 1 plus 1 is 2, so 2 plus 2 into cos 60 degree. How much is cos 60 degree? Cos 60 degree is half. So this 2 and 2 is gone. So this comes out to be root 3. Yes, Aviral, you are absolutely right. ठीक है? So the resultant will have a magnitude of root 3. ठीक है? इसको डायरेक्ट रिजल्ट से भी सॉल्व कर सकते थे. Now these are two vectors, they are equal in magnitude. हाँ कि ना? Vector A also has a magnitude 1, vector B also has a magnitude 1. So we can directly use the result we had discussed. What was the result? 2p cos theta by 2. Can you remember that? Can you recall that? Two vectors equal in magnitude, the resultant is 2p cos theta by 2. So this becomes 2 multiplied by 1 and cos theta by 2. cos 60 degree by 2 matlab cos 30 degree. So this will be root 3. So from there also we can calculate it. No, it will be root 3. How root 2? It should be root 3. Alright, chalo. Let's go to the next question. Now this question might be a little difficult for you, but all the knowledge that you have from this session, you can use it to find the answer. Try it once. It's an interesting question. A little bit difficult for you, for everyone who is studying vectors for the first time. This might be a little bit difficult, but you know all the tools. You have all the tools. I have told you all the tools that you would require to solve this question. तो थोड़ा apply करना पड़ेगा. Try it out. So you have been shown the forces, the magnitude and direction is shown. The angle between any two successive consecutive forces is 45 degree. So this is 45 degree, this is 45 degree, this is 45 degree. All these angles are 45 degree. We have to find out the magnitude of the resultant. Go for it. Try once and then we are going to see the solution. Alright, now can we add vectors which are anti-parallel? Let's think about that. Let me redraw it over here. Just think about, can we add vectors which are anti-parallel to each other? How do we add vectors which are anti-parallel to each other? Sir, can you draw one time which resultant we'd find? We have to find the resultant of all the forces. How many forces do you see? You see 8 forces. We have to find the resultant of all these 8 forces. Don't worry, we are going to simplify it. First of all, what do you see? This is 8 Newton, this is 4 Newton. They are pointing in the opposite directions, which means they are anti-parallel. Do you remember? So if the angle between the vectors is 180 degree, then what is the magnitude of the resultant? The magnitude of the resultant is magnitude of P minus magnitude of Q. Do you recall this? If they are in the opposite direction, then what is the resultant? Resultant is simply the difference of the two vectors' magnitudes. So if this is 8 Newton and this is 4 Newton, can I say the resultant of these two vectors is going to be 4 Newton like this? ये बात समझ में आई कि नहीं आई? Is this clear? We have just seen special cases of vector addition. When they are in the same direction, they get added directly, and when they are in opposite direction, they get subtracted. Correct? So if I take this 8 Newton and 4 Newton, the resultant is 4 Newton in this direction. Now you have a hint. Now this is 7 Newton and this is 3 Newton. Again they are facing, so they are pointing opposite, which means the resultant is going to be 4 Newton like this. For this 7 Newton and 3 Newton, the resultant is going to be 4 Newton like this. This 6 Newton and 2 Newton, the resultant is going to be 4 Newton like this. And for this 5 Newton and 1 Newton, the resultant is going to be 4 Newton like this. Is this clear? Hi Tazeen, let's concentrate on this session. यहाँ तक सब समझ में आया कि नहीं आया? इसके आगे का step we'll see. But are you able to understand this? This special case that we have learned. अगर clear है, then give me a thumbs up. Kanishk, next class for advanced is tomorrow at 11 a.m. Okay, we are going to do Doppler effect. We are going to do in-depth analysis of Doppler effect. ठीक है, चलिए. So what do I have finally? What I have finally is I have 4 vectors. All of them are equal in magnitude. All these have a magnitude of 4. Now what I want to do is I want to find out the resultant. Okay. Now there is another special case that I had just taught you. If two vectors are inclined at 90 degree, then what is the resultant? If theta is equal to 90 degree, then what is the magnitude of the resultant? The magnitude of the resultant becomes p square plus q square under root. Is that right? Yes or no? Okay, so I'm going to draw it with a different ink. So I want you to focus on this vector and this vector. Are these two vectors inclined at 90 degree? Yes, they are inclined at 90 degree. Their magnitude is 4 and 4, which means the resultant of this 4 and 4 is going to be how much? The resultant of this 4 and 4 is going to be 4 square plus 4 square under root, which means this is going to be 4 root 2, the first result. If the angle between the vectors is 90 degree, then the resultant will have a magnitude of p square plus q square under root. So I have done that. Now another result I have just told you, that if we have vectors with the same magnitude, then the resultant is going to go through the angle bisector, which means the resultant of 4 and 4 is going to go something like this. Do you agree? It is going to go along the angle bisector. So now what do I have? I have this vector which has a magnitude of 4 root 2, and I have this yellow vector which has a magnitude of 4. Now what we can do is we can forget about this vector and we can forget about this vector. Now from 4 vectors I am left with how many vectors? I am left with 3 vectors. Is this clear? Okay. Now look at this vector which is in blue and look at this vector which is in yellow. Are both the vectors in the same direction? Do you agree? Are both the vectors in the same direction? If the vectors are in the same direction, if theta is equal to 0 degree, then the resultant has a magnitude of simply p plus q. Which means if this blue vector which has a magnitude of 4 root 2 and yellow vector which has a magnitude of 4, if I add them, what will be the resultant? The resultant would be something like this. The magnitude is going to become 4 plus 4 root 2. Correct? So now I have one vector which has a magnitude of 4 plus 4 root 2 and I have another vector which has a magnitude of 4. What will be the resultant? The angle between them is how much? The angle between them is 90 degree. And if the angle between them is 90 degree, what is the resultant? It's p square plus q square under root. So this is going to become 4 plus 4 root 2 square plus 4 square, the under root of that. This is going to be my final result. Is this clear? Okay, it was not an easy question. Let's find the final answer. So I can take out 4 square. So this is going to become 4 square and then 1 plus root 2 ka square plus 4 square. And then 4 square I can take out of the under root. So this is going to be 4. 1 plus root 2 square is going to be 1 plus 2 root 2. And then we have a 1 over here. So finally the result is going to be 4 into under root of 4 plus root 2. This is going to be the final answer. Okay, complicated. The question was a bit complicated, but we have solved this question using all the concepts we have learned today itself. Okay, what are the key concepts here? The magnitude of the resultant if the vectors are parallel, magnitude of the resultant if the vectors are anti-parallel, magnitude of the resultant if the angle between the vectors is 90°, and that if there are vectors equal in magnitude, the resultant is going to pass through the angle bisector. All these concepts combined that we learned today, we have applied it in this question. Alright, clear? So if everything is clear, quickly give me a thumbs up, quickly give me a yes, and if you enjoyed this video, if you enjoyed this session, do like this session as well. Alright, so that is it from my side today. Next session, we are going to continue our discussion with vectors. So I'm going to see you in the next session. Till then, keep practicing, keep getting better, and have fun with learning. Thanks for watching, guys. Take care. Bye-bye.